Hey guys, welcome back. So what we're looking at today is 3.10, puzzling over polynomials. So let's go ahead and jump right in. So what we're looking at here is we want to reduce the expression to the lowest possible terms and assume no denominator equals 0. So here we have 3x over 6x squared. Notice, what do they have in common? Well, there's an x in the top and there's an x squared in the bottom. So we can cancel out the squared with the x. We're still left with one x down there. Then 3 and 6, those both cancel. Or the 3 will cancel and the 6 will turn into 2. So we have 1 over 2x. Number 2, we have 2 times 5 times x times x times x times y. And we have 3 times 5 times x times y times y. Well, cancel out what they have in common from top to bottom. So we're left with 2x squared over 3y. And that's our answer. Number 4, we've got x plus 2 over x plus 2 and x minus 9 over x minus 9. Those things both cancel, so we're left with 1. So sometimes everything might cancel. So here, be careful. Notice things are a little different. We've got 8x minus 7, and it's in parentheses, and we've got an 8x on the outside here. Those can't cancel. Then we have the x plus 3 and the x plus 3. Those can. And so we're left with 8x minus 7 over 8x times 2x minus 3. So we have to be careful when canceling. If it's in a parentheses, like over here, we've got 3x and 3x, but one's added 17, one's subtract 5. So we can't cancel the 3x out because it's contained in those parentheses. So looking at these, we are reducing these to their lowest possible expression. So cancel what they have in common, but make sure it's completely in common. Make sure of those negatives and positives. All right. For the next section we're looking at here, we are reviewing features of polynomials. Polynomials is your key word for this lesson. So we have the function x cubed. The function in factored form would just be f of x equals x times x times x. The end behavior, so it might help to take and have it graphed before we do the end behavior. So let me get the axes on here. Oops, too big. Okay, so let's make this our y-axis. Kinda, sorta. Alright, so we have our y-axis and we have our x-axis. Okay, so for our function, if we plug in 0, we're going to get 0. 0 cubed is still 0. So there's that point. If we plug in 1, 1 times 1 times 1 is still 1. If we plug in 2, 2 times 2 times 2 is 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right, now if we plug in -1, we're going to get -1. If we plug in -2, we're going to get -8. So 1, 2, 3, 4, 5, 6, 7, 8. So there is our function with points. I'm going to try to draw the curve that goes between them. So it's going to look something like this. So there is our graph. So now for end behavior, as x goes to negative infinity, f of x goes to, well, as x is going negatively, so is f of x. So let me change this back. So it's going to negative infinity. And as x approaches positive infinity, well, look, it's going to positive infinity. All right. Roots with multiplicity. So we just have the one root, x equals 0, and its multiplicity, I'm just going to put mult, is 3 because we have 3 roots all with 0 because we have 3 x's there. The degree, remember, that's our exponent, so the degree is 3. And the value of leading coefficient, well, we don't have one, it's just 1. So looking at different functions as well as being able to determine the factored form, what the graph looks like, that end behavior, what the roots are, the degree, and the leading coefficient. So here you're given it in factored form, so you're going to be given different forms each time. So you may have the graph, you may have the factored form. We're going to go ahead and do 13 because trying to pull the information from the graph can be a little tricky. But if we think about factored form, we know we have an x plus 2, because that would be this point right here. We have just an x, because that's the 0. We have x minus 1, and we have x minus 2. For end behavior, as it goes to negative infinity, it's going positively. As it's going to positive infinity, it's going in a positive direction. The roots are -2, 0, 1, and 2. We saw that. Because there are 4 roots, that means it's a degree 4. And the y-intercept is at 0, 0. Now, for the equation, what we do is we take and we multiply this all together. So I'd use FOIL to do this first part here. So I'm going to write it on top of the graph. So we'd have x squared, minus 2x minus 1x plus 2. So we'd have x squared minus 3x plus 2. And we need to multiply that by this over here. Now I'm going to distribute the x in there. So we'd have x squared plus 2x. X squared plus 2x. So x squared times x squared is going to give us x to the 4th. X squared times a negative 3x will give us negative 3x to the 3rd. X squared times 2 is 2x squared. 2x times x squared is another plus 2, or 2x to the 3rd, I should say. And then 2x times negative 3x is negative 6x squared. And 2x times 2 is plus 4x. Okay, so now we simplify all of this. We only have one x to the 4th, so x to the 4th. We have a negative 3x here and a positive 2x to the 3rd here. So negative 3 plus 2 is a negative x to the 3rd. Then we have positive 2x minus 6x squared. So 2 minus 6 is negative 4x squared. And then last but not least, that 4x. So there it is in standard form. So multiplying it all through. All right. So then you have a couple more. So there's another one. So use your roots. You've got 2 roots here. Use those to help you. This is actually a to the 3rd power. So be careful. Your roots are 0 and 3 with a mult of 2. So factored form would be negative 2x times x minus 3 times x minus 3. So use that to help you in getting yours in standard form. All right. So for these, you're finishing the graph. If it's an even function, remember if it's even, they're both going to go to infinity. If it's odd, one will go to infinity, the other will go to negative infinity. So that's what you'll be doing there. All right, the last section, writing polynomials given the zeros and the leading coefficient. So write the polynomial function in standard form given the leading coefficient and zeros of the function. So we know the leading coefficient is 2, and we have our roots of 2, root 2, and negative root 2. So what that tells us is we have x minus 2 and x squared minus 2 with a 2 out front. So taking our x times x squared, we'll get x to the third, x times, x times negative 2 will be a negative 2x, inner negative 2 times x squared minus 2x squared, then last plus 4. And then we still have to multiply everything by 2 because that 2 out front for our leading coefficient. So 2 times x to the third is 2x to the third minus 4x squared minus 4x plus 8. So that's what you guys will be doing here for these, okay? All right. The last section is fill in the blanks to make a true statement. If f of b equals 0, then a factor of b must be 0. The rate of change in a linear function is always a constant amount. The rate of change of a quadratic function is linear. The rate of change in a cubic function is quadratic. And last but not least, the rate of change of a polynomial function of degree n can be described by a function of degree. Well, if we look, linear is constant, so that went down 1. Quadratic is linear. Cubic is quadratic. We're going down by 1 each time, so n minus 1. All right, if you guys have any questions, feel free to ask. Have a great day. Bye, guys.